Hello, children. Welcome to Right Tuition Classes. We are doing ICC Physics. We're going to do the numericals. We're going to do the numericals. Chapter 1, force. Okay, Chapter 1, force. So first, let's see the formulas involved. Okay, the first of the formulas is the moment of force. Okay, what is the moment of force, children? Moment of force is equal to is equal to okay force into distance of the force from the axis of rotation. Distance of force from axis of rotation. Okay, distance of force from axis of rotation. So yaad rakho beta, this is the first formula I'm telling. Moment of force is equal to force into distance of force from the axis of rotation. You can call it as perpendicular distance of force from axis of rotation. Okay, now if you ask me, it's SI unit. What is SI unit? Okay, what is SI units? Okay, SI units. Okay, of moment of force. SI unit of moment of force. Okay, what is it be beta? In force formula में देखो force F stands for force and this distance of force from the axis of rotation, so Newton. Are you getting me? Distance, sorry, meter. Got it? Force into, sorry, unit of force is, I'm so sorry, unit of force is Newton. Children, SI unit of force is Newton. Okay, SI unit of force is Newton, and please here Newton into what is this, children? Meter. Newton into meter. Okay, you can write it in short as Newton meter. Got it? And what is CGS unit, Peter? Please here, CGS unit. CGS unit is CGS unit. Okay, not a SI unit. The earlier one was SI unit, and what is CGS unit? Okay, SI unit. Now, earlier one was SI unit. Now we're going to see CGS unit. In place of Newton, it will become dyne. Okay, forces in dyne into centimeter. Okay, children. So that can be written as dyne centimeter. Got it? We cannot write it in short like this only. Okay. Then, children, there is gravitational units also. Now, what are gravitational units of moment of force? Gravitational unit. Okay. Gravitational units. Okay. Gravitational units of moment of force. Okay, in that also, I'll put it like, got it? There is an SI unit as well as in SI unit, okay? Gravitational units may SI unit, okay? Gravitational unit may SI unit, okay? What it will be? This will be the forces, the unit of force in gravitational is kgf. What it is? Kgf, okay? Into meter, correct? Into meter. So we just write it as kgf meter, correct? Kgf meter. And what is CGS unit, gravitational unit, okay? It is same beta. It will be gf into centimeter. So either just say kgf meter, okay? And gf centimeter, correct? So remember this, children. You should know it, and then you should also know 1 kgf. Listen, this is about gravitational unit, okay? Then 1 kgf, just have a look at it. 1 kgf meter, 1 kgf meter is equal to 9.8 Newton meter. 9.8 Newton meter. Got it? 1 GF centimeter. 1 GF centimeter is equal to 980 times centimeter. Okay, 180 dynes ne, dynes plural nahi aayega beta. 180 dyne. Okay, dyne. They'll test you here. You know, many of the children will write plural. It should be singular. 980 dyne centimeter. Okay, 1 GF centimeter is 980 dynes centimeter. Got it? Okay, I hope people understood me here. Okay, now we go ahead with the numericals. 1 minute, children, we'll just revise it. I hope people will get it, understand it. See, we have learned the what you can say the moment of force. What is moment of force, Beta? Moment of force is a formula, like I told you. The moment of force is force into perpendicular distance of the force from the axis of rotation. Moment of force formula is what? Force into perpendicular distance of the axis of perpendicular distance of the force from the axis of rotation. Got it? This is it. Okay. So remember, children, you cannot afford to forget it. Very simple question will come, and you have to get that marks. Okay, 2 mark question will come on it. Okay, and you have to get it. Correct? Now look here, children. In the same way, if you ask me the SI units, okay, the SI units of moment of force. You can see here the SI unit of moment of force is what, beta? You can see Newton meter. What it will be? Newton meter. What it will be? Newton meter. Okay, Newton meter. Then in the same way, when you look at it, what is the CGS unit? CGS unit, you can see a bit of dyne centimeter. What it is? Dyne centimeter. These are units. I'm talking about units. Okay, you should know the units also. They ask these units also sometimes for 1 mark question. Okay, so you cannot forget it. And these are gravitational units in both, children. Gravitational units in what you can say is in moment of force. You can see here, children. I'll just show it to you. This is it, okay? Oh, yeah. Gravitational units, you can see here, children. Okay. I hope people understood me here. We go to the next, okay? Now, another formula, what you should know is about movement of couple, okay? Now, one more thing you should know about clockwise and anti-clockwise movement. What do you mean by clockwise movement? Clockwise movement, okay? And anti-clockwise movement. What do you mean by clockwise movement, okay? If the effect of force is if the effect of force is to rotate the body in clockwise direction. If the effect of force is to rotate the body in clockwise direction, then the moment of force is called moment of force is called clockwise movement. Clockwise movement. Clockwise movement. Okay, and what is more important here? Why did I make it? Why did I write here? Now you can see here, children, why I wrote. Okay, there's conventionally matlab rule. Okay, conventionally, doing calculation, while doing calculations for clockwise movement, while doing clockwise movement, got it? We should put negative sign, negative sign. Got it? So conventionally, understand this, while doing calculations for clockwise movement, we should put negative sign. Are you getting me? We should put negative sign. I should not, of course, I need no need of putting bracket here. We should put negative sign. Okay, it's only conventionally means negative sign matlab clockwise movement hai. Got it? And what do you mean by anti-clockwise movement, children? What do you mean by anti-clockwise movement? Anti-clockwise movement. Anti-clockwise movement. Okay. So remember, just opposite beta, just opposite. What is that? Okay. If the effect of force, effect of force, if the effect of force is to rotate, rotate the body in anti-clockwise direction, anti-clockwise direction, then the moment of force, moment of force is called anti-clockwise movement, okay, movement. The movement of force is called anti-clockwise movement. And when you're doing calculations, remember, conventionally, okay, while doing calculations for anti-clockwise movement, we should put positive sign. We should put positive sign. Okay, we should put positive sign. So remember, children, clockwise movement can also be called as negative movement of force, and anti-clockwise movement can also be called as positive movement of force. So you should be able to guess it. Okay, we should be able to understand, remember it. Okay, anyhow, now we go to the next formula beta. The next formula is about movement of couple. Okay, the next formula is about movement of couple, or you can movement of couple. Now, what is movement of couple? Movement of couple is again the second formula. Okay, now, we are coming to the second formula. Movement of couple, movement of couple is equal to, now this please have a look here. Movement of couple is equal to either force. We just use the word either force. मतलब couple मतलब दो force act हो रहा है. These two forces are equal in magnitude, opposite in direction, and the line of action is parallel. Got it? So such a pair of forces are called couple force. Now it turns a body. So we want the movement of couple. Okay, that effect is called movement of couple. I want to measure this moment of couple, this effect of turning. Okay, so the moment of couple is equal to what it is, either force, means both these forces are equal, so any one of this force into distance between, into perpendicular distance between, perpendicular distance between the two forces, between the two forces. Now listen, this perpendicular distance between the two forces is also called as arm of the couple. We also call them as arm of the couple. That means this formula can also be written as either force into, what is this perpendicular distance between the two? We can also call it as arm of the couple. What do you call it? Arm of couple. Okay, no problem. Okay, we can also call it as arm of couple. So remember this formula, beta. Moment of couple is given by the formula either force into perpendicular distance between the two forces. Okay, so again, if you see the SI unit and CGS unit, gravitational units, okay, all are same, just like moment of force. Are you getting me here? SI unit will be Newton meter. CGS unit will be dyne centimeter. But gravitational unit, gravitational SI unit will be kilogram. What it will be? Okay, kgf, kgf. The force, unit of force is kgf. And unit of distance will be meter, okay, kgf meter, okay. And CGS unit, gravitational unit of force is gf, centimeter, gf, centimeter. It will be same like this, okay. Now, this is, you should know, then what is that? Please here, whenever, see, then one very important thing, okay, according to principle of movements, according to principle of movements, if the body is in equilibrium, then understand, if the body is in, according to principle of movements, if the body is in equilibrium, then, right, some of the anti-clockwise movements, some of anti-clockwise movements is equal to sum of clockwise movements, okay. Please understand this, beta. In many of the problems we'll be using this, okay. Okay, now what we do is we start with some simple numericals, okay. The numericals of this based on this, okay. So we are going to start with the numericals, children. Please be attentive. These are numericals, okay. Very simple. It will be asked in your board exam. Got it? So okay. Now only remember, for a uniform body, the weight of it always acts at its midpoint, geometrical midpoint, correct? At its midpoint. I'll make you understand. Like scale, if they say uniform scale, then weight of the scale acts exactly at its midpoint. Are you getting me here? Got it? Suppose it's a meter scale, okay, 100 centimeter scale. Then its weight, it's a uniform meter scale. Get it? So see here. So it's a 100 centimeter scale. That means its weight will be exactly at its 50 centimeter mark. Are you getting me here? 50 centimeter mark. Okay, anyhow, just remember this, okay? Now, the first of this question, I'll just write, okay, the first of this question, I'll say the moment of force, okay, the moment of a force of 10 Newton about a fixed point O, about a fixed point O, is 5 Newton meter. Calculate the distance of point O. Distance of point O from the line of action of force. From the line of action of force. Line of action of force. From the, okay, so remember this, children. Very simple, very easy. Okay, we will first, what you do in physics problems, okay, always we'll try to write it in short first, okay, whatever is given, okay, like please see a solution, okay, I'm going to write the answer for it, you just call it a solution. Okay, the moment of force of 10 Newton, the moment of force of 10 Newton about a fixed point. Looking at the unit, you can realize this is only force, okay? F, okay? What is F, children? 10 Newton. What is F? 10 Newton. The moment of force of 10 Newton about a fixed point is 5 Newton. Oh, this is moment of force. So you look at the unit, okay? The unit is Newton meter. So this, what is this moment of force is equal to, children? 5 Newton meter. I hope everybody understands. Now calculate the distance of O from the line of action of force. What they want is the distance. Okay, they want the distance. Okay, so what is the formula, beta? Formula is moment of force का formula है. Moment of force जब भी रहेगा तो उसको moment of force का formula से याद रखना है. Moment of force is force into perpendicular distance from the line of action of force. Force into perpendicular distance from the line of action of force. What is that? Force into perpendicular distance. I just call it as distance. Okay, let's not waste time. It's perpendicular distance of the force from the axis of rotation, whatever you call it. Okay, force is 10 and this is 5. Okay, Newton into, oh, sorry, force is 10 and moment of force is 5 Newton meter. Got it? So I'll put it like this, children. In place of, in place of moment of force, I'm going to put 5 Newton meter. Don't worry about the unit. You can put the unit. Okay, or even if you don't put the units, here will do. Okay, force ka jagah mein 10 Newton into distance. Okay, so I want distance, children. So 10 Newton will go down. Okay, so 5 Newton meter upon 10 Newton. Now, what all cancels? Remember, the units will also get cancelled. Okay, so you can see here 5 ones are 5 twos are. Got it? And Newton gets cancelled. So it is half meter, the number alone and units to the side. So distance is half meter. Half is 0.5. Okay. So we'll write the answer the way they have asked. So when you look at it, the way they asked the question, they want to calculate the distance of the point O from the line of action of force. Okay. So we'll write like this. Therefore, distance of point O, therefore distance of point O from line of action of force, line of action of force is equal to 0 is equal to, what you can say is half Newton meter, half Newton meter, half meter, sorry, that is nothing but 0.5 meter. Got it? So this becomes your answer. I hope people understood me here. So always you have to write the answer. Got it? You have to write, children, if you want to get full marks. Okay, if you don't write it, the teachers can always cut marks. Okay, so can cut marks. I'm not saying will cut marks. Okay, depends on the teacher to teacher. Some teachers are very, like, liberal, they will give you marks. Okay, other teachers will cut your marks for sure. Okay, so this was about the first question. Okay, children. Now we have to start with the. We have to. We start with the second question, children. We have to start with the second question. You can see, children, question number 2. A nut is opened by a wrench of length 10 centimeter. Got it? What is a wrench? Wrench is nothing but a spanner. Okay. A nut is opened by a wrench of length 10 centimeter. That means this is distance like. Okay. Now, if the least force required is 5 Newton, least force required is 5 Newton, find the moment of force needed to turn the nut. So when you look at it carefully, children, see here, force is F is equal to 5 Newton. Okay. And this length of the wrench is nothing but your distance, distance from the axis of rotation. Okay. Length of wrench. I'll call it as length of wrench only. Okay. Because the question is on length. Okay. How much it is? 10 centimeter. So always I told my students the first thing that given information, whatever is there, whether they are in the same units. Oh, this is Newton, MKS, SI unit, and 10 centimeter is CGS. 10 centimeter should be converted into meter. How do you convert a centimeter to meter divided by 100? Okay, when I divide by 100, it gets converted into meters. So 1 0 cut, 1 by 10. Now, what they wanted to find, children, they wanted to find the moment of force. Okay, moment of force. Now, what is the formula for moment of force, children? So everybody knows moment of force is equal to moment of force is equal to what it will be, children? Length of this force into length of the wrench. I'll talk. We are doing about the sum, okay? Please here, length is nothing but distance, I suppose, okay? Everybody realizes. Now, what is this force, beta? We got it as phi. What is this length? Phi Newton, okay? And what we have got length of the wrench. We have got 1 upon 10 meter, got it? So what will happen, children? It will become phi upon 10 Newton meter. Now people will say, why am I not cancelling? When 5 upon 10, I can always write it as 0.5 Newton meter, got it? So what is the answer, beta? The answer, again, I'll tell you, I told my students, I'll always write the answer the way it's given in the question. They've asked in the question, okay? The moment of force needed to turn the nut. So what am I going to write here? The moment of force needed to turn the nut. Moment of force needed to turn the nut, to turn the nut is equal to कितना आएगा बेटा? Is equal to 0.5 Newton meter. Got it? So this is your answer. And always remember, children, your answer should be put in a box. Okay? That is one way of presentation. Okay? Like you put it in a box. Answer put in a box. The teacher can look at it easily. So that's it with the second question, children. Very easy. And I'm sure everybody must have got it. Okay. Understood the second question. Okay. We go to the next question, children. Question number 3, children. A wheel of diameter 2 meter is shown in the adjacent figure with the axle at O. Here is O. Axle मतलब एक रॉड पास होता रहेगा O से और ये व्हील और रॉड में घूमेगा. Then that rod is called an axle. Correct? Axle को ऊपर rod को ऊपर ये wheel घूमेगा. So that rod is called an axle. Correct? So wheel of diameter 2 meter is shown in the adjacent figure from axle at O. Now, a force F 2 Newton, a force of F equals 2 Newton is applied at point B. ऐसा apply किया आपने force को apply किया तो wheel कैसे घूमेगा आगे जाएगा wheel will go ahead wheel sorry it's sorry wheel will not go ahead okay a force F of 2 Newton is applied at B in the direction as shown in the figure. You can see the arrow okay in this direction. Now calculate the moment of force about the center O. मतलब अभी एक्सल पास हो रहा है व्हील आगे नहीं जा रहा है करेक्ट तो ये घूम रहा है इसके ऊपर ही सो what is the moment of force about O? So O is the axis of rotation. So what is the distance of the force from the axis of rotation? So for the first one, I'll put it like this. Got it? F is equal to how much? 2 Newton. F is equal to 2 Newton beta. Okay. Distance of, please here, distance of force from axis of rotation, purposely to make you understand, I'm writing the whole thing, is nothing but it's R actually, radius of the wheel, which will be half into diameter. And what is diameter given to you? Diameter of wheel is given to you as 2 meter. Okay, diameter of wheel is also 2 meter. You can see here. So naturally, half into diameter, half into 2 meter. कितना आएगा बेटा? 1 meter. Got it? So distance of force from the axis of rotation also I know. Got it? 1 meter. Now can I get the first part is movement of force about the center O. So what is movement of force about the center? We are doing the first part only. Movement of force about center O. About center O is equal to what I'll be? It'll be force F into distance. Now what is this? Distance of force from the axis of rotation. So what is this 2 Newton? What is this 1 meter? I got the distance as, you can see I got the distance as 1 meter. Got it? So how much you get, children? This will be 2 Newton meter. And remember one thing better, this rotation, the direction of rotation is this way, okay? The direction of rotation is clockwise. You can see here. So I better write clockwise here. Clockwise. Are you getting me here? Got it? Now, this is the answer. Okay, moment of force about center O equal, what is it? Moment of force about center O. Moment of force about center O is equal to 2 Newton meter क्लॉकवाइज करेक्ट देखो अभी मैंने फिर से ऊपर भी लिखा है वापस लिख रहा हूं बिकॉज ये आंसर है बेटा आंसर लिखने का यू हैव टू राइट एन आंसर इन अ बॉक्स ओके इफ यू डोंट राइट द आंसर इन अ बॉक्स करेक्ट योर टीचर्स actually find it difficult to correct okay because once they see the answer and the answer is perfect they'll not see the above things what you've written they may give you full marks okay that is the way they try to go fast in the correction okay so anyhow this was about the first part now we go to the second part now what is the second part listen second part I'm doing the second part children now in the second part they want the movement of force about point A. They want the movement of force about point A. मतलब now this axle is not there. ये axle है ही नहीं बेटा. ये O में axle था ना इसको भूल जाओ. ओके सेंटर में एक्सल था भूल जाओ. एक व्हील है ग्राउंड के ऊपर है आप इधर से फोर्स लगाएंगे तो ए है ना ए इज इन कांटेक्ट विद द वॉल विद द फ्लोर तो ये घूमेगा व्हील आगे जाएगा ओके so naturally what is the moment of force here so for the second part again force is 2 Newton okay but the distance of this varies. Okay, distance of force from axis of rotation. Axis of rotation. Now it is something different. Okay, it is equal to diameter. Is equal to diameter, children. That is nothing but 2 meter. Got it? 2 meter. Axis of rotation ना इधर तक है, B से A तक distance. Okay. So now what will happen, children? The moment of force, moment of force about point A is equal to force into the distance. Beta. What is this distance, children? You can see here this distance. I written here, underline it. Distance is 2 meter. So this is 2 Newton into 2 meters. So what I get? 2 into 2, 4. 4 Newton meter. What I get, children? 4 Newton meter. What I get, children? 4 Newton meter. And again, you can see here, children, it has turned clockwise. It has turned clockwise. Are you getting me? So I put it in a bracket. So here, answer moment of force about point A is equal to what it will be, better? 4 Newton meter clockwise. Clockwise. Are you getting me here? You better put it inside a bracket. Okay, doesn't matter. Okay, but put it, underline it. Now, when you underline it, when you underline it, well, put it in a box. Okay, highlighting the answer is a must. Highlighting the answer is a must, I tell you, children, because really it helps a teacher to correct the papers better. Okay, anyhow, we go to the next sum now. Look here, very simple. We are going slow, children, but very soon I'll be going little catch up the speed. Okay.